I'm connected with two screens because I want to share you my slides. Do you see my slides?
Yes.
Ladies and gentlemen, distinguished colleagues, it is an honor to be here today. We are about to discuss a field that has undergone an extraordinary transformation, moving from simply describing aging to actively intervening in it. We are in the area of interventional geroscience, but this new power presents us with a central tension. The core of my talk today is about, are these new interventions truly enhancing longevity, or are they introducing profound potential risks? I'm Dr. Mohammad Bodaghabadi, Assistant Professor of Geriatric Medicine, University of Semnan from Iran. The backdrop for this discussion is a global demographic shift. Global life expectancy has nearly doubled in the last century. But this success has revealed our next great challenge, the gap between lifespan and health span. The World Health Organization estimates by 2050 over 2.1 billion people will be over the age of 60. The economic and healthcare implications are staggering. This makes longevity science not just a biomedical pursuit, but a global public health priority. Our goal is shifting from simply treating late life disease to maintaining lifelong resilience. And this is not the theory. The data shows this field is in override. A bibliometric analysis of the last decade shows an exponential rise in research. Over 14,800 index studies with a 17% annual growth rate. The top domains, cellular senescence, NAD+, metabolisms, and epigenetics. Crucially, translation from the bench to the bedside is already underway. We have the TAME trial. It is testing metformin to delay composite of age-related disease in over 3,000 people. Disease like heart disease, stroke, or CKDs. But the data now is unpublished and still going. The trial is still going. The PER trial is evaluating rapamycin analogs for immune rejuvenation. Pilot studies at the Mayo Clinic using the senolytic dasatinib plus quercetin have already shown they can reduce inflammatory SSAP factors in humans. It is reduced senescent cells. And just last year, a study in Nature showed partial epigenetic reprogramming could reverse visual decline in primates. They are injected vectors to the vitreous, and they seen the visual declines reversed in the primates. The science is moving at a breakneck pace. So, what we are targeting? Our understanding is unified by the hallmarks of aging. This framework provides a map of interconnected biological processes that drive aging. You see them here, from genomic instability and telomere attrition to mitochondrial dysfunction, the cellular senescence. The key concept, as established previously, is that these not 9 separate problems, they are deeply interconnected networks. Mitochondrial dysfunction fuels inflammation, senescence cells causes epigenetic drift. This means that targeting one critical node might slow the entire network. Today, we will walk through the most previous interventions for these hallmarks. Let's begin. Let's begin with one of the most consistent features of aging, inflammations. This is the chronic, low-grade smoldering fire driven by senescent cells, mitochondrial reactive oxygen species, and gut dysbiosis. This can modulate, we can modulate these lifestyle interventions like caloric restrictions or regular exercises and um, nutraceuticals like resveratrol, quercetin, curcumin, omega-3, uh, and drugs like rapamycin. They can reduce the inflammation. But this is our first double-edged sword. Blunt immune suppression increases the infection and cancer risk. Furthermore, high-dose antioxidants can actually blunt hormesis, the beneficial stress signaling our cells need to adapt and get stronger. Another intervention, telomerase activations. Telomeres, the protective caps on our chromosomes, they act as a cellular fuse, shortening with each division until the cell enters senescence. The idea is simple. Re-extend them. Interventions ranged from supplements like TA65 to experimental gene therapies that express telomerase reverse transcriptase, the core enzyme of telomerase. But thinking about the risk, here we are meeting the biggest dragon in the field, cancers. 85 to 95% of all human cancers achieve their immortality by reactivating telomerase. In our quest for rejuvenation, we risk arming premalignant cells with the very tool they need to become immortal. Okay. About the epigenetic modulations. If DNA is the hardware, the epigenome is the software. Aging involves epigenetic drift, a loss of youthful gene expression. We can now measure this biological age using epigenetic clocks. This is perhaps the most exciting frontier. We can tune up the software with sirtuin activators, NAD plus precursors, or we can perform a hard reset using partial cellular reprogramming with Yamanaka factors. It can turn back adult cells to pluripotent cells. As you know, the risks are profound. Complete reprogramming, area cellular identity, potentially leading to tumors or teratomas. We are learning to control this, but the danger of tumorigenesis is paramount. Proteostasis is cellular protein quality control. Its failure is the story of Alzheimer's disease and Parkinson's. The accumulation of toxic misfolded proteins, beta amyloids, and taus. We can enhance autophagy, the cell's self-eating or recycling programs. This is the primary mechanisms of caloric restriction. And it's how rapamycin and spermidine are believed to work. This is paradox. While autophagy clears damage, it can also be hijacked by cancer cells to survive metabolic stress and chemotherapy. Furthermore, excessive autophagy can tip into autophagic cells death. Another area is mitochondrial health. Our mitochondria are our cellular engines. With age, they fail, leading to an energy crisis and more oxidative stress. A key reason is that NAD plus levels decline by nearly 50% between youth and old age. This led to explosion of NAD plus precursors like NMN and nitric amine mononucleotide and NR. Our approaches like ornithine A that is found in pomegranates or um, nuts, certain nuts, work by boosting mitophagy, the specific clearance of damaged mitochondria. Yet again, we face the cancer paradox. Cancer cells are highly metabolic and love NAD+. By supplementing supraphysiologic levels of NAD+, are we inadvertently superfueling the metabolisms and DNA repair of the premalignant cells? The question is unresolved. These are master regulators of cellular economy. Think of mTOR as the growth and build signal, and AMPK as the conserve and repair signal. Aging is characterized by chronic overactivation of mTOR. This gives us our two most famous geroprotective drugs, rapamycin, which inhibits mTOR tricking by the body into fasted states, and metformin, which activates AMPK, mimicking the energy deficit by mimicking the energy deficit of exercise. These are powerful drugs and not simple supplements. Chronic rapamycin are well known to cause metabolic side effects like including glucose intolerance and dyslipidemia. Another intervention, senolytics. This brings us to zombie cells. Senescent cells stop dividing but refuse to die. Instead, they accumulate and secrete a toxic pro-inflammatory cocktails called SSAPs. This led to revolutionary idea, senolytics, or drugs that selectively kills these zombie cells. The combination of dasatinib and quercetin is the most famous example. But thinking about the risks, we need senescence. It is critical. Primary defense against cancer. It is also vital for our wound healing. If we clear these cells too aggressively, we risk impairing tissue repair and, ironically, removing one of our body's key anti-tumor barriers. Another intervention, stem cell therapies. Our body's regenerative engine, our stem cell pools, become exhausted with age. their niche degrades and their numerous doing this. The goal is to restore this. This includes mesenchymal stem cell transplantation and use of iPSC, include pluripotent cells, and now cell-free exomes therapies. The risk is obvious and profound. Tumorigenic potential. Incompletely differentiated iPSCs can form teratomas. This is perhaps the highest risk, highest rewards area of all. Microbiome modulation. We are now beginning to understand that the gut aging axis, age-related dysbiosis, and a leaky gut allows bacterial toxins like lipopolysaccharides to enter circulations, driving systemic inflammations. We can intervene with diet, probiotics, the most radical interventions. As known in animal models, the fecal microbiota transplantation or FMT from young, healthy donors is used as an examination. FMT, but about the risks. FMT is not benign. It carries a very real risk of pathogen transmissions and can have unpredictable outcomes. In immunocompromised individuals, even simple probiotics can pose risk of sepsis. About the core of challenge, summary of risks. Let us summarize this central theme. The challenge of translational geroscience is defined by these risks. The translational gap. What works in a genetically identical mouse is a sterile cage from often fails in complex heterogeneous humans. The ongoing risk. You hear it again and again. Telomerase activation, partial reprogram, high dose NAD+, and stem cell therapies all share a common shadow, the potential to induce or accelerate cancers. Metabolic and systematic side effects. Rapamycin impact on glucosenolytic impact on wound healing. Biomarker limitations. We are still struggling to find reliable, standardized biomarkers of biological age. How do we prove the interventions in working without a 30-year mortality trial? And there is some ethical and socio-ethical risks. Equity and access. Will these interventions, if successful, be available only to the wealthy? Are we prepared for a longevity divide that exacerbates social inequality? Resource allocations. What does a world with a longer living population means for our healthcare system, our pension funds, and our planet's resources? And finally, regulations. The FDA does not officially recognize aging as a treatable disease. This creates a massive hurdles for drug approval and opens the door for a flood of unverified high-risk products. I want to conclude my speaking. So, where does this leave us? It leaves us at a crossroads. The old paradigm of finding one magic pill to be taken chronically is clearly too high risk. the future is outlined in our final session must be on the precision germplasm. This means personalization using omics and AI to determine who needs what intervention. It means dynamic modulations using interventions cyclically like a course of senolytics rather than chronically to get the benefit while minimizing the risk. And it means combination therapy, layering low risk, low dose interventions. Thank you for your listening to my speaking. And the goal is not just to add your years to life, but to add life to years. Thank you very much. I would happy to take your question.
Hi, I have a question. What do you comment about peptides and I'm sorry, there's a term for it, but smaller molecule peptides?
May I may I ask you to tell me about examples of these peptides?
There are many drugs, for example, were created as peptides, the GLP-1 for weight loss and all that. But there are other type of
GLP-1.
peptides, the body protective compound, the thymosin type of peptides, the thymus gland and hormone production decline due to age, just like the NAD situation. So there are the new approach using peptides to address chronic disease or complex disease that take years to heal, and using the peptide to shorten the length of treatment. But it also being looked at for anti-aging purposes. I just wanted to hear your comment about what do you think about peptide use in that anti-aging approach, frontier, and then the risk?
The GLP-1 drugs that recently introduced to the market, and it is used by the celebrities to lose the weight. Very commonly used these peptides, but they are should be in the markets, and after after their safety, we can tell the patients that they can safely use these drugs. But you can see there is some complaints about the blindness of these drugs that is very, you can see in the internet, there are complaints of the blindness, and we can see this in the internet. There are complaints about these drugs. And I think we can wait until their safety, we can find they are safe, and we can tell the patients that they can use them safely.